Okay, geometry students, in this video we're going to be looking at conditional statements. Okay, we are going to be looking at conditional statements. They're also called if-then statements. Now, you don't need to write all this down. I will tell you when you need to write stuff down, okay? But we're going to be looking at conditional statements today. They are also called if-then statements. This is one of those topics that is fundamental in geometry. Fundamental. So please take really good notes, and if you have to, watch the video again tonight at your house, okay? And be sure and ask the supervising teacher to pause the video if you need to. Your heading today is called Conditional Statements. The lesson number is lesson 2.4, and do also please include today's date in your notes. Okay, now here is an example of a conditional statement. Please write this down. If you study for at least 3 hours, then you will pass, then you will pass your test. Please copy that in your notes. If you study for at least 3 hours, then you will pass your test. Now, I want you to notice a lot of things about this sentence, okay? First of all, it is called a conditional statement because we have a condition. Now, you don't need to write that down. You can if you want to. That's up to you. There's a condition being made. If you do something, then you'll get something in return. If you study for at least 3 hours, then you will pass your test. Okay? And so that's why it's called a conditional statement. Would you please take some more stoats? Would you please take some more notes, students? I want you to make note, please write this down, that this is called the if part and this is called the then part. You need to know that. We will quite often in this class say, look at the if part or look at the then part, okay? There are other words that you need to know, okay? This is called also the hypothesis, okay? Sorry about that. The hypothesis. So the if part is called the if part. It's also called the hypotenuse, the hypothesis, excuse me, and the then part is called the conclusion. Okay, this is called the conclusion over here. Now, I do not know the answer to this question, and so if you ask, I will not be able to answer it. But in geometry, and this is true in all geometry books, they use the letter P to refer to the if part, and they use the letter Q to refer to the then part. Now, I'm not sure why, but you need to know that. Please write that down. So let's review for a second. We are looking at conditional statements, and conditional statements are called conditional statements because there's a condition. If something happens, then something else will happen. And we call this the if part or the hypothesis. We call this the then part or the conclusion. And we also can call the if part the P part and this over here the Q part. And you'll see this quite often in geometry too. Write this down, please. In geometry too. Geometry also, okay? You will see this in geometry also. The letter P, write this down please, in 2 lines and an arrow, and then the letter Q. And this means, please write this down, if I can get my pen to work here, this means P implies Q. If P, then Q. Okay, so write all that down. Let it pause for a second. P implies Q, or you could also say if P, then Q. All right, if P, then Q. So this is what we're going to study today, conditional statements. Now, I want us to look at the converse of this conditional statement. Okay, now I'll tell you when you need to write stuff down. Just listen, okay? Write this in your notes. Now, hold on, before you do, let's go back. Here is the original statement right here. If you study for at least 3 hours, then you will pass the test. Now what we're going to do is we're going to swap the P and the Q. And when you do that, it's called a it's called a converse statement. Here it is. Write this in your notes, please. If you pass the test, then you studied for at least 3 hours. This is called the converse. Please write that down. Write this statement down and then make note it's called the converse. Do you see how I switched things around? The other statement said, if you study for at least 3 hours, then you will pass the test. Now I'm saying, if you pass the test, then you studied for at least 3 hours. So when you swap the P and the Q, we call this the converse of the original statement, the converse. Do you see what I did? Now don't write this down again. I will tell you when to write stuff down. Do you see what I did? I swapped the hypothesis and the conclusion, and that is how you write a converse statement. Did you also notice that the converse is not true? It is not true. If I say to you, if you study for at least 3 hours, then you'll pass your test. Okay, let's just pretend that's a true statement. You study for 3 hours, you pass your test. Well, the converse isn't true. You can't say, if you pass the test, then you studied for at least 3 hours. It might be that you passed the test because you got lucky, or you passed the test because you cheated, or you passed the test because you're a genius. Okay, so notice that the converse in this situation here, now think about it, guys. Notice the converse is not true. Okay, and you need to understand that. Okay, because just because a conditional statement is true does not mean its converse is true. And this needs to be written in your notes, so please write that down. Just because a conditional statement is true does not mean that its converse will also be true. And you need to know that. I'm going to pause a second while you quickly write this down. And if you're kind of doubting me, I'm going to give you a real good example in just a second, okay? All right, I'm going to move on, but this sentence here will stay up here so you can continue to write it down while you're listening, okay? Here we go. Now, don't write this next comment down, just listen, okay? Just sit back, relax, finish writing this statement, and listen. Here's a true statement. Here it is. And a lot of you know I have a Prius that I drive, okay? So, if you have a Prius, then you have a car. Now, that is definitely a true statement. You can't argue with that. If you have a Prius, then you definitely have a car because a Prius is a car. Now, watch this. That's a true statement. But listen to the converse now, okay? Remember, don't write this down, just listen. Now I'm going to swap these two things here, okay? If you have a car, then you have a Prius. Well, that's not necessarily true at all. It might be true, but you can't be guaranteed that it's true. This is always true. If you have a Prius, then you have a car. But this isn't always true. If you have a car, you might have a Mustang. You might have an Accord. You might have whatever. So just because a conditional statement is true does not mean that its converse is also true. You really, really need to get that, okay? All right, now this is obviously not true. Like I just said, you can definitely have a car that's not a Prius. Okay, now let's practice working with some conditional statements. Okay, let's practice. Contain your excitement. I know you just can't wait to do that, so here we go. I would like you to write this in your notes, please. If the measure of angle A equals 30 degrees, then angle A is acute. Please write that down. If the measure of angle A is 30 degrees, then angle A is acute. Now, first of all, I want you to tell me, is that true or false? If an angle is 30, then it's acute. Yeah, that's true, definitely. Now, on your own, or you can watch me, I want you to write the converse of this, okay? So here we go. Write the converse. If, and we'll say angle A. If angle A is acute, then its measure is 30 degrees. Now you might have written this a little differently. You might have said if angle A is acute, then angle A equals 30. That's totally fine. There's more than one way to do this, but the main thing is I picked up this part here and put it over here, and I picked up this part here and put it over here. Okay, so let's see if that's true. Is it? If angle A is acute, then its measure is 30. No, that's not necessarily true. If angle A is acute, it can be any angle less than 90. It could be 30, 40, 50, 60, 70, 80, 10, 15, 19. Okay? All right, let's try another one. So here's what we did. We decided whether or not this was true. Then we wrote the converse, and then we're going to label that false. Okay? So let's try another one. I want you to write this in your notes, please. Write this down. If the measure of angle A is 90, then angle A is a right angle. Please write that down. If the measure of angle A equals 90 degrees, then angle A is a right angle. Copy that down, please. Okay, now let's decide whether or not this is true. If an angle is 90 degrees, then it's a right angle. I have no problem with that. That's definitely true. Now, on your own, I want you to go ahead and write the converse. Okay, so you can look up here and watch me do it. I'm going to do it quietly, or you can do it on your own and look up when you're finished. Go ahead and write the converse of this. Okay, here we go. I swapped the two places, the P and the Q. If angle A is a right angle, just symbolism here, right angle, then the measure of angle A equals 90. Well, if you have a right angle, it will measure 90. That is also true. So here's an example of a statement in which the original if-then statement was true, and then the converse was also true. So that will happen sometimes. Okay? All right, let's continue on. Write this one in your notes if you would, please. If angle A is obtuse, then angle A is 120 degrees. Why don't we go ahead and do this? I'm going to have the supervising teacher pause the video. I want you to decide whether or not this is true or false, and then I want you to write the converse, and then I want you to decide whether or not the converse is true or false. Okay, so go ahead and pause the video at this time and go ahead and do that. Okay, hopefully you guys did well on this. Let's see how you did. If angle A is obtuse, then angle A is 120 degrees. Now students, that's false. If you put true, think about it. If angle A is obtuse, then angle A is 120. It might be, but it could be 130, 140, 150, 95. It could be any angle greater than 90 and less than 180. Okay, so that's not necessarily true. Okay, it might be, but we can't say for sure it's always true. Now let's turn it around. Let's write the converse. If angle A equals 120 degrees, I should put a little m right here for measure. If the measure of angle A equals 120 degrees, then angle A is obtuse. And that's definitely true. This is the converse right here. We wrote the converse, and that's true. If an angle is 120 degrees, then the angle is obtuse. And that is definitely true. That is true. All right, let's continue on. Let's go back up to this second statement right here. Students, now listen to me. Let's go back up here and let's talk about this for a second. Notice that this was an example in which the statement was true and so was the converse. Do you remember that? Okay, well, let's talk about this statement for just a second. When this happens, when the original statement is true and its converse is true, we call this a biconditional statement. So you might want to make a note of that and draw a line or something. This is called a biconditional statement because the original statement is true and its converse is true. All right? There is a special expression. Please listen to me, students. There is a special expression that we use for biconditional statements. And the expression is if and only if. When you see this expression, you know that in geometry, the expression is a biconditional statement. Now, I would write this down. Okay? I would write that down, and somehow make note about this too, okay? There's a special expression that we use for biconditional statements. The expression is if and only if. And when you see this expression, you know that in geometry, the expression is a biconditional statement, okay? I'm going to pause for a couple seconds while you write this down. Okay, this will stay up here for a couple more minutes here. Let's continue on. Let me show you what I mean. I am going to rewrite the expression above using if and only if. So let's think about this. Remember, we already decided this is a biconditional statement. So now I'm going to rewrite this statement using if and only if. Write this down. Here it comes. Okay? An angle is a right angle if and only if it is 90. Okay? Now, look, I didn't use if and then. I mean, if's in a sentence, but I didn't start off with the word if. Okay? I just said, actually, I started with this part first, and that's fine. In just a second, I'm going to do it the other way, okay? So if you're wondering, does it matter which part you start off with first? It does not matter. No, it does not. So an angle is a right angle, so an angle is a right angle, or I could have said angle A, whatever, if and only if it is 90 degrees. Now I'm going to do it again using if and only if, only I'm going to write this part first. So here it comes. Write this down also. Write this statement down here, and then also write this next statement down. An angle measures 90 degrees if and only if it is a right angle. Either one of these two statements is acceptable, okay? And notice both of these statements are written using what? If and only if. So write these two statements down so you're getting used to seeing that, so you know how to write them on your own. If I ask you to take a statement and write it using if and only if, make sure you understand how to do this. Definitely write this in your notes, please. So whenever you see an if and only if statement in geometry, you know immediately that it is a biconditional statement. Please write this in your notes. This is really important. I'm going to continue on, but this will stay up here for a while, okay? Now, I want you to take some statements and write them in if-then form. You can work ahead or stay with me, whatever you want to do, okay? But let's take some statements and let's write them in if-then form. This is something you should be able to do, so let's practice this, okay? All right, now these can be really tricky, so please pay attention. Students, please pay attention. Write this in your notes. The defendant was in Dallas only on Saturdays. The defendant was in Dallas only on Saturdays. Now, I want you to write this in your notes, and I want you to write it now using if and then. Now, here's the problem. Please listen to me. Should you start off if the defendant was in Dallas, then it's a Saturday, or should you start off if it's a Saturday, then the defendant is in Dallas? And of course, I'm just scribbling here. I'm not really trying to write neatly. Do you see what I'm saying? Do you put your if part here, or do you put your if part here? And it's real important you think about that, because one way's true and one way's not in this case here. Now, the defendant was in Dallas only on Saturdays, okay? But does it say anywhere the defendant was in Dallas on, please listen to me, every Saturday? Does it say that anywhere? No. So you can't say if it's a Saturday, the defendant's in Dallas. You can't say that. But what you can say is this. You can say if the defendant was in Dallas, then it was a Saturday. Because it says right here, the defendant is in Dallas only on Saturdays. Let this sink in, guys. You can't say, if it's a Saturday, then the defendant was in Dallas. No, he doesn't come every Saturday, but when he's there, it's a Saturday. Okay, this can be confusing, so really think this through. I want you to try another one. Please write this statement in your notes. Court begins only if it is 10 o'clock in the morning. Court begins only if it's 10 o'clock in the morning. Now you can wait for me and just copy down what I put, or you can try to work ahead on your own. I want you to write this statement in if-then form. Now you have to ask yourself, should I start off saying if court begins, then it's 10 o'clock, or should I start off saying if it's 10 o'clock, then court has begun? Well, let's think this through. It says court begins only if it's 10 o'clock, okay? But nowhere does it say that every single time it's 10 o'clock in the morning, court will be in session. It's not saying that. It's saying court begins when it's 10 o'clock. But there are some days, maybe a Saturday, maybe a Sunday, when court's not going to be open. So you can't say if it's 10 o'clock, then the court is open. But what you can say is if court begins, then it's 10 o'clock. So I'm taking these statements, students, and I'm writing them in if-then form. And I hope you're getting this, okay? If court begins, then it is 10 o'clock in the morning, or 10 a.m., all right? Now, I want you to practice writing a biconditional statement using if and only if, okay? So I want you to practice this. Here's the statement. Please write this down. An equilateral triangle has three congruent angles. Now, I know you're thinking, oh, Mr. Earhart messed up. It's three congruent sides. No, an equilateral triangle also has three congruent angles. We'll get into that later. But for right now, just copy this statement down. An equilateral triangle has three congruent angles. Now, this is, by the way, this is, hold on one second, students. Thank you. This is a biconditional statement. Let me show you how I know that. If I said, if I have an equilateral triangle, then it has three congruent angles. That's true. And then I said, if a polygon, or if a figure has three, or if a triangle has three congruent angles, then it is an equilateral triangle. That is true. So this statement here is true, and its converse is true. So I would like you to practice writing this using if and only if. Okay, I'm going to help you. You would start off by saying a triangle is an equilateral triangle if and only if it has three congruent angles. A lot of symbolism you can use in geometry, by the way. So I took the first part. Notice when you're writing a statement using if and only if, you don't start off with if like you do in an if-then statement. You don't do that, okay? So I took the first part, equilateral triangle, and I put that first, which is fine. A triangle is an equilateral triangle if and only if it has three congruent angles. Now I'm going to turn it around. You could also say this: a triangle with three congruent angles. So now I'm putting this part first, okay? Write this down. A triangle with three congruent angles, and let's see, how do I want to word this here? Okay, I left one word out, sorry about that. A triangle, let's see, what was I going to say? A triangle is an equilateral triangle if and only if, okay? A triangle has, sorry about that, students, that's really embarrassing, sorry. A triangle has three congruent angles if and only if it is an equilateral triangle. Sorry about the dead time there, okay? So a triangle is an equilateral triangle if and only if it has three congruent angles. A triangle has three congruent angles if and only if it is an equilateral triangle. So you can write a biconditional statement using if and only if two different ways. Okay, both of those are fine. One is not better than the other. Okay, let's continue on. Let me get a drink here real quick. And we are almost done. We're going to wrap up this video, students, looking at 6 postulates and then some examples. Now, 6 sounds like a lot, but they are 6 very simple, very easy, very quick postulates, okay? So I do want you to write these 6 postulates down. And here we go. Postulate number 5, write this down. Through any 2 distinct points, there exists exactly one line. And that's so obvious, students. While you're copying this down, I'll comment on it. If you got a point here and a point here, how many lines can you draw through those 2 points? Only one. And that's all that this is saying. Through any 2 distinct points, there exists exactly one line. Okay? Postulate 6. A line contains at least 2 points. Well, again, that's one of the, I want to say, duh. I mean, that's just so obvious. I mean, look, if you have one point like this, that's not a line, okay? But as soon as you draw a line, there's at least 2 points on that line. There has to be, okay? So a line contains at least 2 points. Piece of cake. All right, postulate number 7. Write this down. Through any 3 non-collinear points, there exists exactly one plane. Now the 3 points, let me read that again. Through any 3, keyword here, non-collinear points, there exists exactly one plane. Now if you have 3 points that are in a straight line like this, well, then you could have a lot of different things. You could have a plane that intersects those there, and I have no drawing skills. You could have another plane that comes down and intersects, and I can hear you all laughing right now. I just have no drawing skills whatsoever. But you could have another plane that intersects, and that's why this word here, non-collinear, is so important, okay? If your 3 points are not, on a straight line like this, then only one plane can pass through all 3 of those points. Only one plane. And that's what this is saying. Through any 3 non-collinear points, there exists exactly one plane. Postulate number 8. A plane contains at least 3 non-collinear points. Of course. I mean, if you have 2 points, it might be a plane, but it could just be a line, okay? So if you have 3 non-collinear points, if you have a plane, you're going to have at least 3 non-collinear points. You have to, okay? A plane contains at least 3 non-collinear points. All right, number 9, if 2 distinct points lie in a plane, then the line containing them lies in the plane also. And my voice is starting to go, so we're going to wrap this up. If 2 distinct points lie in a plane, then the line containing them lies in the plane also. And that's just, guys, that's just saying, look, here's a plane, here's 2 points. If these 2 points lie in a plane, and then you connect those 2 points with the line, isn't it common sense the line will also lie in the plane? Sure it is. If you take a sheet of paper and put a point here and a point here, those 2 points lie on the plane. And then if you draw a line that connects those 2 points, that line also has to lie in the plane. And that's all that postulate number 9 is saying. And then postulate number 10, if two distinct planes intersect, then their intersection is a line. Okay? If two distinct planes intersect, then their intersection is a line. And we've talked about that before. If two planes intersect, then their intersection is a line. And we have talked about that before. Now, very quickly, literally like 60 seconds, please get out your books and turn to page 81. I want to quickly look at numbers 5 through 8. And they're quick, very easy answers, okay? Very quick problems. So here we go. Please turn your books to page 81. I will pause for just a minute. We're going to look at numbers 5 through 8. Page 81, numbers 5 through 8. Okay, here we go. Number 5 reads as follows. The points X, Y, and Z lie in a plane. Okay, here we go. Get my pen working here. Okay, the points X, Y, and Z lie in a plane. Now the directions say state the postulate that verifies that truth. Well, they're three non-collinear points, so they have to lie in a plane. So what postulate would that be? Well, here it is. Through any three non-collinear points, there exists exactly one plane. Or we could say a plane contains at least three non-collinear points. This is going to be the one right here, because what we have is, we are told that we have, if you look at number 5, X, Y, and Z, 3 points. So, through any three non-collinear points, there exists exactly one plane. So you would use postulate 7. Let's take a look at number 6. The points X and Y lie on a line. So the points X and Y lie on a line. And that's going to be the postulate that states through any two distinct points there is exactly one line. Through any two distinct points, postulate 5, there exists exactly one line. Okay? Let's take a look at number 7. The planes A and B intersect in a line. Well, this one's going to be obvious. Planes A and B intersect in a line. Well, look at the last postulate we just learned. If two planes intersect, their intersection is a line. So there we go. Postulate number 10. And now let's look at number 6, number 8. The points X and Y lie in plane B. Therefore, line M lies in plane B. Well, look at this postulate right here. If two distinct points lie in a plane, then the line containing them lies in the plane also. Okay, so there we go. All right, it's a pretty long video. That's why we're not going to have any homework today, but I hope this has been a help. I hope you're understanding this. Make sure you're taking really good notes and contact me if you have any questions.